Welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 4 to the power of x equals 2 root 2. So our goal here is to find the value of x. Now what we're first going to do is we're going to change our square root of 2 here to 2 to the power of 1/2. Because remember, the square root is simply that number to the power of 1/2. And we still are multiplying this with 2. So this is equal to 4 to the power of x still. Now, a to the power of b times a to the power of c is equal to a to the power of b plus c, right? This is how we multiply exponents. So 2 times 2 to the power of 1/2, well, 2 is the same thing as 2 to the power of 1. So we're essentially adding 1 and 1/2. So we have 2 to the power of 1 plus 1/2, and 1 plus 1/2 is 3/2. This is still equal to 4 to the power of x. Now 4 is actually the same thing as 2 squared. So I'm going to replace 4 with 2 squared. So we have 2 squared to the power of x equals, excuse me, 2 to the power of 3/2. Now, if we have something in the form a to the power of m to the power of n, this is the same thing as a to the power of m times n. So 2 to the power of 2 to the power of x, this is the same thing as 2 to the power of 2 times x, which is just 2x. And this is equal to 2 to the power of 3/2. Now, because our bases here are the same, our exponents here are the same as well, meaning 2x is equal to 3/2. And now, as you see, we have a simple equation. So now if I multiply by 2 on both sides, I get 4x is equal to 3. And now if I divide by 4 on both sides, I get x is equal to 3/4. So this is our answer. To Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 2 to the power of m minus 2 to the power of n equals 2016. So what I'm first going to do is I'm going to set m equal to n plus k, k being a constant. Now, if this is true, then we also know that n is equal to m minus k. And k is a constant. So now what I'm going to do is I'm going to replace m with n plus k. So I'm going to rewrite this as 2 to the power of n plus k minus 2 to the power of n equals 2016. Now, if we have something in the form a to the power of n plus m, this can also be written as a to the power of n times a to the power of m. So 2 to the power of n plus k, this can be written as 2 to the power of n times 2 to the power of k. And we are still subtracting this with 2 to the power of n, and this is equal to 2016. So now what I'm going to do is I'm actually going to rewrite 2016 as 2 to the power of 5 times 63. And this is still equal to, what I'm going to do is I'm going to factor out 2 to the power of n from this. So if I factor out 2 to the power of n, I get 2 to the power of n times 2 to the power of k divided by 2 to the power of n is simply 2 to the power of k, and 2 to the power of n divided by 2 to the power of n is 1, so minus 1. So we get 2 to the power of n times 2 to the power of k minus 1, and this is still equal to 2 to the power of 5 times 63. Now, as you can see, this is even, so I'm writing E for even. This is going to be odd. I'm going to write an O for odd, and this is odd because we're going to subtract 1 from the 2 to the power of k. This is 2 to the power of n, so any number that you plug in, this would be even because it's 2 to the power of something, and 2 is an even number. However, we're still going to subtract 1, so this is actually going to be odd. And now from this, remember, this is even. 2 to the power of anything will result in an even number, and 63 is odd. So I'm writing O for odd. Now what I'm going to do is I'm going to set the evens equal to each other. So 2 to the power of n equals 2 to the power of 5. And because these two have the same bases, we know that the exponents are equal to each other, meaning n is equal to 5. And now what we're going to do is we're going to set the odds equal to each other. So 2 to the power of k minus 1 is equal to 63. So now if I add 1 on both sides, I get 2 to the power of k equals 63 plus 1 is 64. And what 2 to the power of what equals 64? 6. So k is equal to 6. So we know that m is equal to n plus k. So we already have the values for n and k. N is 5 and k is 6. Meaning m is equal to 5 plus 6, which is 11. So m is 11. So now we have our values for n and m.